Our today's topic is General Equilibrium, Edgeworth box. Let's begin with partial equilibrium and general equilibrium analysis. Partial equilibrium analysis is the study of equilibrium in one market in isolation. Therefore, it focuses on explaining the determination of price and quantity in a given product or factor market when one market is viewed as independent of the other markets. On the other hand, general equilibrium analysis deals with explaining simultaneous equilibrium in all markets when price and quantities of all products and factors are considered as variables. Thus, in general equilibrium analysis, the interrelationship among markets of all products and factors are explicitly taken into account to determine the market prices of several goods. Let's move on to the next topic, that is Edgeworth box. Edgeworth box is a graphical representation of the exchange problem faced by the parties in a two-good, two-individual exchange economy. Now, let us discuss it in detail. A common tool in general equilibrium analysis is the Edgeworth box, which allows the study of the interaction of two individuals trading two different commodities. This type of analysis draws on the use of indifference curve analysis to analyze this trading behavior. Edgeworth box diagram has been used to explain the general equilibrium of distribution of two goods between two individuals. Edgeworth consumption box shows the indifference curves of the two individuals A and B, describing their scale of preferences for the two goods. As we move upward from bottom left to top right, individual A moves to the higher indifference curves and individual B moves to the lower indifference curves. This figure shows that general exchange equilibrium would lie somewhere on the contract curve, that is the curve QT that passes through the tangency points of indifference curves of the two individuals. At these tangency points, MRS XY of individual A equals to MRS XY of individual B, which indicates the occurrence of general equilibrium of exchange between the two individuals. Since the equality of MRS XY of the two individuals exists at all points of the contract curve, it is not possible to know at which specific point the general equilibrium of exchange will be reached. However, if the initial distribution of two goods X and Y between the two individuals A and B is known, it will be possible to find the boundaries within which the equilibrium of exchange would lie. Thus, in this figure, if the initial distribution of X and Y between A and B is represented by C, then the individual A has XA1 amount of good X and YA1 amount of good Y. The remaining quantity of good X, that is X0 minus XA1 is equals to XB1, would be allocated to individual B, and the remaining YB1 quantity of good Y would go to the individual B. At this level of distribution, the indifference curve of the two individuals are intersecting, but at point C cannot be the position of equilibrium for the two individuals, since both of them can gain or become better off if they exchange some quantities of goods possessed by them and move to the contract curve. If through exchange of goods they move to point R on the contract curve, individual B reaches on higher indifference curve B4 that makes him better off, while individual A is no worse off as he remains on the same indifference curve A2. On the other hand, if they move to point S on the contract curve, individual A becomes better off and individual B is no worse off as compared to the initial position C. However, if they move to any point between R and S on the contract curve, both the individuals will gain, as they will be reaching at higher indifference curves. Where exactly on the contract curve their equilibrium position of exchange will lie depends upon the bargaining power of each individual. With almost equal bargaining power of each individual, the equilibrium position of exchange on the contract curve may lie at point E, where both of them will gain almost equality. At point E on the contract curve, individual A will exchange CK amount of commodity X for KE amount of commodity Y. Since point E lies on the contract curve, which is the locus of the tangency point of indifference curves of the two individuals, marginal rate of substitution between the two goods, that is MRSXY of individual A, equals to marginal rate of substitution between the two goods MRSXY of individual B. Thus, exchange of CK amount of commodity X for KE amount of commodity Y will be settled between them at the equilibrium position E. The features of general equilibrium of exchange attained at point E on the contract curve are: first is the individual maximize their satisfaction. Another is the exchange of goods between the two individuals implies that the quantity sold of each good equal the quantity purchased of the good. Next is the general exchange equilibrium also determines the exchange rate, that is relative prices of the two goods. Next, the general equilibrium of exchange does not lead to the determination of absolute prices of goods, but only relative prices of goods. Another is, in Edgeworth box, the general equilibrium of exchange of the goods must lie on contract curve, otherwise their MRSXY will differ from each other. Moving on to the next topic, that is Edgeworth box general equilibrium of exchange and production. Factors of production are required to produce goods, and the level of production depends upon the allocation of resources. Two goods and two factors analysis of general equilibrium considers 4 markets, of which 2 are product markets and 2 are factor markets. Any change in the use of one factor for the production of goods X and Y will also affect the use of other factor. Thus, the general equilibrium analysis determines the pattern of relative prices and the quantities of the goods and factors at which all markets clear together, and the 4 markets attain equilibrium simultaneously. The analysis is based on the certain assumptions such as: first is all units of labor are homogeneous and receive equal wages. Similar assumption is made for capital also. Another is availability of labor and capital is fixed, and both of them are fully employed and utilized in the economy. Another is production function allows transfer of labor and capital from one good to the other. Another is technology is given, which together with the factor endowments limits the production possibilities. Now let us discuss the next topic, which is Edgeworth production box and general equilibrium of production. Dimensions of the Edgeworth production box represent the available fixed quantities of the two factors labor and capital. In this figure, the horizontal axis measure the quantity of labor and the vertical axis measure the quantity of capital. For products X and Y, various isochrones are drawn in the box. For good X, the isochrones drawn that represent successfully higher levels of output are X0, X1, X2, X3, etc. with the bottom left hand corner OX as their origin. Similarly, for good Y, the isochrones that represent successfully higher levels of output like Y0, Y1, Y2 and Y3 etc. are drawn with the top right hand corner OY as the origin. This figure shows that points R, M, Q and H are the tangency points of different isochrones of good X and Y. A curve RH joining the tangency points of isochrones is called the production contract curve. The general equilibrium of production under competitive conditions in the factor markets would lie somewhere on this production contract curve. Various points in the box represent alternative allocations of factors between the two goods. For example, point T in the box shows that OXL1 or K1T amount of labor and OXK1 or we can say L1T amount of capital are allocated to produce X, and the remaining amount of labor TF and the remaining amount of capital TC are allocated to produce good Y. But point T does not represent equilibrium position, because from point T the economy can move to a point M or N on the contract curve by reallocating resources between the two goods, where the output of one good increases without the reduction in the output of the other good. By reallocation of factors, if the economy moves to any point between M and N on the contract curve, say to point Q, the outputs of both the goods X and Y would be higher than at T. Thus, resource allocation implies by a point on the contract curve leads to greater output than those not on the contract curve. Since the slope of an isequent measures the marginal rate of technical substitution between the two factors labor and capital, that is MRS LK, at various points on the contract curve, the MRTS LK of x is equals to MRTS LK of y. The general equilibrium of reduction would lie at the efficient point on the contract curve. In this figure, given here initial vector allocation at point T, if general equilibrium of production occurs at point Q on the contract curve RH, it will determine the allocation of factors between the two goods and also the equilibrium production of the two goods. Thus, the general equilibrium of production at point Q states that output X2 of good X and Y2 of good Y is determined. Besides, the general equilibrium of reduction also determines the ratio of factor prices, that is the exchange rate of labor for capital. Thus, at point Q, Ts amount of labor will be exchanged for Qs amount of capital. However, on the production contract curve, the exact point at which the general equilibrium of production occurs depends upon the demand for goods X and Y. If the demand for good X is relatively higher than that of the good Y, the equilibrium of reduction would take place on the upper point, like N on the contract curve RH, where a larger quantity of good X and smaller quantity of good Y is produced. On the other hand, for low demand for X and high demand for Y, the production equilibrium will occur at a lower point on the contract curve, which indicates smaller amount of output of X and larger output of Y. Thus, the exact point of equilibrium on the contract curve depends upon the specific consumer demand for goods X and Y, which in turn depends on the initial ownership of factors and the factor prices. Thus, the general equilibrium of production requires the simultaneous equilibrium of the two factor markets that determine the allocation of resources for the production of two goods. For an economy with many goods and many factors, the general equilibrium of production requires that the marginal rate of technical substitution between any pair of factors is the same for all goods and all producers are using the same pair of factors. Moving further with next topic, that is general equilibrium of production and exchange. There are several points on the transformation curve. Each point indicates a different price ratio of the two goods and also a different production equilibrium that states a different output mix of two goods. The general equilibrium of production can occur at any of the points on the given transformation curve depending upon the prevailing price ratio of the two goods. General equilibrium level of price ratio Px divided by Py, or the marginal rate of transformation MRTXY, will be the one at which the profits of firms and also consumer satisfaction is maximum. To analyze the general equilibrium of output mix, consumer preference pattern or demand for goods is introduced. If the MRSXY of the consumers is not equals to MRTXY in production, the consumer satisfaction will not be maximized, due to which the further changes in the price ratio of two goods and output mix will tend to occur. Since MRTXY shows the rate at which one good is transformed into another in the production process, and marginal rate of substitution measures the rate at which consumers are willing to exchange one good for the another. Equilibrium cannot be reached unless the two rates are equal. If the free market economy, the forces of competition would ensure the adjustments in the output mix of the two commodities such that MRSXY is equals to MRTXY. General equilibrium of production together with the general equilibrium of exchange or consumption requires that the marginal rate of transformation, that is MRTXY, must be equals to marginal rate of substitution, which is MRSXY, of the consumer and also of the MRSXY of the two consumers must be equals to each other. Thus, for the achievement of general equilibrium of production and exchange simultaneously, MRTXY must be equals to MRSXY of A, which is also equals to MRSXY of B. overall general equilibrium of production and exchange is explained using these figures. In this figure, a production transformation curve Tt dash is drawn. Consider point L on the curve Tt dash at which OM of good X and ON of good Y are produced. With the given preference pattern and resource endowments of the two consumers, their indifference curves are drawn within the box which are tangent to each other at point S, and their MRS XY is indicated by the slope of the tangent like KK dash. This figure shows that the MRS XY of consumers at point S is less than MRT XY of producers at point L, indicating that production pattern is inconsistent with the consumer preferences. Thus, the system is in disequilibrium because the firms produce relatively greater quantity of X and smaller quantity Y is being produced than demanded by the consumers. In response to this disequilibrium situation and to maximize profits, the producers tend to produce more of Y and less of X, and the process of adjustment in output mix will continue until the MRT XY in production is brought into equality with MRS XY of consumers. With this equality, general equilibrium of production and exchange will be attained, which is represented in this figure. At the point Q dash on production transformation curve Tt dash, in this figure, OX2 level of output of X and OY2 level of output of Y are produced, and MRT XY at point Q dash is equals to MRS XY at point E. Slopes of JJ dash and PP dash are equal. It means that producers are in equilibrium because at Q dash the marginal rate of transformation MRT XY is equals to the price ratio, which is Px by Py. As measured by the slope of Pp dash, there is general equilibrium of exchange or consumption as MRS XY of the two individuals are the same, their indifference curves being tangent to each other at point E. There is joint equilibrium of production and exchange as the MRT XY, which determines the price ratio Px by Py at point Q dash, also equals the MRX XY of the two individuals at the consumption equilibrium point E. Thus, with point Q dash on transformation curve Tt dash and point E on the consumption contract curve drawn in the Edgeworth box made from point Q dash, the following condition of general equilibrium of production and consumption is fulfilled. That is, MRT XY is equals to Px divided by Py, which is equals to MRS XY of A, which is equals to MRS XY of B. General equilibrium of production determines total output X2 of commodity X and total output Y2 of commodity Y. It is with OX2 and OY2 as the dimensions, the Edgeworth box is drawn, and indifference curves of two individuals depicting their scale of preferences are drawn with CC dash as the contract curve. Consumption equilibrium point E reveals that out of total output X2 of good X, the amount XA is being consumed by individual A and the remaining amount of X goes to individual B for his consumption. Out of total output Y2 of commodity Y, the amount YA is consumed by A and the remaining amount by the individual B. At last, let us discuss how general equilibrium determines only relative prices. The microeconomic theory is concerned with the analysis of factors that determines relative prices and not absolute prices. Relative prices is the price of a good or factor when compared with the price of another good or factor. In other words, relative price is the ratio of prices of goods. The analysis of general equilibrium shows that factor prices is the ratio of the prices of labor to the prices of capital. We can say W divided by R, which is measured by the common slope of the isoquants at the tangency points of the relevant isoquants that was determined. Likewise, in general equilibrium of exchange, it was explained how general equilibrium determined the ratio of the prices of two goods, that is Px divided by Py. General equilibrium in this figure is established at point Q dash on the transformation curve Tt dash, where MRT XY is equals to MRS XY of A, which is further equals to MRS XY of B. This yields the relative prices of goods x and y indicated by the ratio px divided by py, which is measured by the slope of the transformation curve at the equilibrium point q dash. It is important to note that it is the relative prices and not the absolute prices that form the general equilibrium analysis show. Therefore, if all the prices change by a common multiplier like doubling or halving of all the prices, then the relative prices will remain the same and hence there will not be any change in the equilibrium position. For example, suppose the relative prices Px divided by Py of two goods x and y as measured by the marginal rate of transformation at point q dash in this figure is 2 by 1, and the relative price of labor and capital, which is W by R as measured by the slope of the I sequence at point q, in this figure it is 3 divided by 1. Further, suppose price of good x is rupees 20 and the price of good y is 10, so that relative product prices are 20 by 10, which is 2 by 1, and the price of labor W is rupees 30 and the price of capital R is rupees 10. So, the relative factor price is W by R is 30 by 10, which is further equals to 3 by 1. Now, if all prices are doubled, Px is equals to 40 and Py is equals to 20 and W is equals to 60, R is equals to 20, then the relative prices of products Px by Py is equals to 40 by 20, which is equals to 2 by 1, and the relative prices W by R is equals to 60 by 20, which is equals to 3 by 1. Since the relative prices have remained unchanged despite a change in their absolute levels, the position of general equilibrium would remain unaltered. In real terms, nothing would change. Consumer would receive twice the payments or income but would buy exactly the same quantities of goods x and y. Each firm would earn double the total revenue than before but would buy and employ the same amounts of factors at the double rate of factor prices. Thus, microeconomic theory lays stress on the determination of relative prices because they are critical in the determination of the real outcome. Now, let us summarize at the end. General equilibrium analysis is used to explain simultaneous equilibrium in all the markets when price and quantities of all products and factors are considered as variables. Edgeworth box is an important method for the analysis of general equilibrium. Edgeworth box allows the study of the interaction of two individuals trading two different commodities. This type of analysis draws on the use of indifference curve analysis to examine this trading behavior. The analysis of general equilibrium is used to determine the relative prices of goods or factors of production. Thank you.